Alright, so this is chapter 13 quiz, probability distribution. So question 1, identify which of the random variables below is categorical. So we can see height, we're talking about height, so that's a number. Body temperature, also a number, measurement. Suburb, so think of the answers, that's definitely going to be in categories. Number of times coin, also number. So we're looking at the suburb of where students live being categorical. All right, question 2. Let's go like that. Question 2, for the following table to represent a probability distribution, x needs to be, so we need all these things to add, this to add to 1, so we've got 1/12, oops, 1/12, we've got 1/6, so I'll make that 2/12 and 1/6. And then we've got something over 12 here, and it's going to add to 1. All right, so we've got 1, 2, 3, 4, 5. So I can see the missing link is 7. I need 7 on 12 in order to add to 1. So that'll be D. So that's how I do my working. All right, so for 3, which of the following is not valid? So the probabilities do not add up to 1. I suspect they do not. There is a negative probability. Yep, that looks wrong as well. There is a probability greater than 1. Yep, that looks wrong as well. So all of the above. All right, so we need to make sure those things are correct for it to be a probability distribution. All right, number 4. So we're looking at the expected profit, and this is over, so it is a bit tricky because it said 2 months. Every month there's 65% chance that he will profit $1,500 and a 35% chance that he loses $1,000. So he's expected to profit 65% of the time, and his profit would be $1,500. So it's like a probability times the score. Minus, because he's expected to lose 35% of the time, how much? 1,000. So when we do that, we get some answer. I didn't write that answer down, but remember that's each month. So if I want, so the same thing, whatever my probability is, remember this is for 2 months, so I'm going to add it up over 2 months. So I'll just double it. So I'm going to get that answer and double it. And I should get 1250. I put that all together in my calculator. So sorry I missed that, the middle step. But I do get D there. I hope that makes sense. So really, this is his expected for each month, basically. Okay? All right, so number 5. Come over here. Number 5 and 6 have the same table. So if we just fill that table in, we've got the probabilities and we've got the score, the x. So the x times the p of x. So I'm just doing 0.2 times negative 750, and that gives me negative 15. 0.43 times 500 gives me 215, etc. So this is an easy one, 450. This is an easy one, 200. If I add those all up, I get 850. And remember, that is giving me E of x, so or mu. So that's my expectation is 850. So in the next one, when it says x minus mu and then all squared, that's exactly what we're going to do. So we take x minus 750 and then minus mu, so minus 850. And actually I'll just write it as, so I'll get minus 1600, and then I'm going to, of course, square that answer. That's a square. So if I do that again, 500, take away 850, so minus 350, and of course we're going to square that. Sorry, I can't fit this in. So 1000, take away 850, so 150, and square that. And 2000, take away 850, which is 1150, and square that. Alright, I'm not going to bother because I don't really need that for anything. But the next one, I'm taking the row above times p of x. So I'm going to do minus 1600 squared times the probability, which is 0.02. and I got 51200. So again, I'm going to take this one and times by 0.43, and I get 52675. And my boxes aren't big enough. 10125 and 132250. Now when I sum that up, I get 246250. Now remember, this is e of x squared, so times p of x here is, sorry, that's not e of x squared. This is, if you look at your formula sheet, this is your variance formula. So this is giving me the variance. So that's my var x. So remember, if I want the standard deviation, I need to square root that to get my standard deviation of x. So the first question asks for the expected profits. So there's my e of x. And the second question asks for the standard deviation, rounded to the nearest whole number. I think I got 496. So this answer here was 496. All right, so just filling in the table, make sure you know how to use it. Okay, so that was 6, 7. All right, we know from, if you can't remember, you can see from your formula booklet that way we did in the table is kind of not very useful, whereas this is much more useful, where we do e of x squared minus e of x all squared. Much more useful. So that's the other variation of the formula that we can use for variance. All right, number 8. For number 8 is just a worded one. So if the standard deviation, all right, so if we've got what's the standard of a distribution that takes one value? Oh, so it only takes one value. So for example, I could have 2, 2, 2, 2. That could be my all my data. 2, 2, 2, 2, 2, 2, for example. If you think about it, it's not deviating, it's staying exactly the same, so the standard deviation is 0. It's not varying, it stays exactly the same, so the variation is 0. If the standard deviation is 0, the variance is 0 anyway, because standard deviation is the square root of the variance. So yeah, so there's no spread of data, it's all in one spot. Alright, number 9. So just remember, when you're doing something like e of 2x minus 1, we know that the 2, it's like algebra, the 2 can come out the front and then the minus 1 can also be separated. That way we can use the e of x, which is 5, so 2 lots of 5s minus 1, so which is 9. So we get an e of x of 9. Now remember, with var we have to be careful with the variance. So the minus 1 from any set of data doesn't do anything to the variance, but the 2 in front does. So but remember, variance is squared, so the 2 becomes a 2 squared out the front of var x, and I do not need to worry about the minus 1. So I get 4 times, where's our var x? Our var x is 3. So we've got 12, so it should be a expectation of 9 and a variance of 12, that is C. All right. And if I look at the last one, sample space of a uniform distribution is that. They're all our numbers. The expected value and the variance of this distribution. Well, the expected value, if we think about it, that's the mean, or the median, or the mode. Well, no mode here. But it's the middle number that we expect if they're all exactly the same distance between them. So, which they are, so just 2, 3, 4, 5, 6, 7, 8. So our expected should only have the 5 there. Should be the 5 right in the middle there. That's what our expectation would be. We don't really need to do it. You could do it using a calculation. So x times the probability. So 2 times, how many numbers do we have? 1, 2, 3, 4, 5, 6, 7. So for example, 2 times we expect that 1/7 of the time, plus 3 times we expect that 1/7 of the time. You could do that, but we don't need to, because we can easily see that 5 would be the e of x here. Now the variance, if you think about it, how varied. So again, you can just think of how varied this is, and you can think, oh, 5 goes out to 8 and 5 goes down to 2. So there's a 3 and a minus 3 here. So the variance it varies by 3. So we're looking at number 10. So each way, so 3 that way and 3 that way. So that's kind of why we usually have the answer as a square, to make, because we're just talking about positive. But here we've got 3 this way, there's 3 this way. So anyway, the variance, is 3. All right, I hope that helps.